Good morning and welcome to the CABE webinar for Wednesday, 18th of January. And today we're looking at waterproofing basements to BS 8102 2022. And we'll cover the importance of using specialist waterproofing designers and contractors and look at the water table classification and grades of waterproofing plus other items. My name is Rosemary and I'll be your moderator today. I'm the Regional Services Coordinator for CABE and I'll be looking after you this morning. We like to make our webinars as interactive as possible, so we do encourage you throughout the session to send in any questions as we go along. If you're watching us live, please use the side panel to send the questions in, and we'll address any of these at the end of the presentation. Alternatively, you can get in touch with us via the social links on screen now. Let me introduce you to today's webinar speaker. Michael Vernon is a qualified waterproofing design specialist with Delta Membranes. He has 18 years experience in the structural waterproofing industry. A broader knowledge of construction and building design gained in his previous architectural career have placed Michael in a unique position to integrate specialist structural waterproofing techniques within the broader scope and challenges posed by constructing with specialist approach. Mike's experience covers designing type A, B and C components with a structure to achieve the correct degree of water tightness required on a project. Michael takes a keen interest in flood-resilient design and integration of specialist materials to produce a variety of solutions, which are complementary and holistic in their approach to respond to specific challenges and expectations. So if you give me a couple of seconds, I will then hand over to Michael and he'll begin his presentation. You share your screen, Michael, then we can you can make a start.
Okay, slideshow. There we go. Can you see that okay, Rosemary?
Yes, thank you.
Brilliant. Okay, I'll start then. Well, hello, everybody. Thanks for joining me on what is quite a snowy morning here in Glossop in the north of England. We're going to talk for 45, 50 minutes or so about the joys of structural waterproofing design, really. As Rosemary has kindly said, I work for Delta Membrane Systems. I've got getting on for nearly 20 years experience now in this industry, designing waterproofing systems for all sorts of buildings, whether they be new build or existing, buildings on contaminated land, buildings at risk of surface water flooding, all sorts of permutations, really. So I like to think that I'm fairly experienced, and I'm going to give you a really practical insight into my world, and hopefully you'll go away from this presentation knowing more than when it started. This is just my business card. You can see on the qualifications, there's a little one called CSSW there, which stands for Certified Surveyor in Structural Waterproofing. So I describe myself as a waterproofing design specialist. Well, how do you identify what one of those is? This qualification is really the key. It's issued by the Property Care Association, and it's industry recognised as representing someone who's qualified to be integrated into a design team and to come up with bespoke and integrated solutions for waterproofing. So that's the CSSW qualification, which is key in my industry. So I just thought I'd point that out. So into the sort of content and the meat of the presentation, we're going to look at quite a lot of aspects of my industry. We're going to look at regulations and legislation, so standards, basically British standards, approved documents, types of waterproofing systems. There are, generically speaking, 3 ways of waterproofing buildings. We're going to look at grades of environment, so any sort of mixed uses, various kind of different ones, such as car parks or plant rooms or occupied environments, and we'll see how that impacts on decisions on design. We're going to look at groundwater, water tables, and the fact that they're variable. Continuity of waterproofing protection. As you might imagine, if systems aren't continuous, then they're not much use for keeping water at bay. Substrates, so we come across various structures like reinforced concrete, blockwork, modular construction, insulated formwork, polystyrene blocks, all sorts of things, really. Compatibility of products and combining systems and risk. Every design solution is based on a risk assessment, and we'll look at what feeds into that and therefore informs the design. So that's the kind of meat of the presentation. Quick introduction to Delta Membrane Systems, seen as the largest UK manufacturer of various products, but we're not just a manufacturer, we're actually more of a technical design consultancy. We see consultancy as being the leader of what we do, technical advice, qualifications, things like that, and the products really come secondary to that. So they follow on from the design rationale and the technical standards. So yes, we're a manufacturer, we make our money from selling products, but we don't just sell products, we give good, solid design advice, and then we go to the most appropriate products that are going to contribute to a successful outcome. So that's the subtle difference, if you like, between us as a manufacturer and also a consultancy, and that's why we're so valuable. We have various publications such as NBS Source, etc., which you can find online, RIBA Product Selector, etc. So I won't dwell too much on those. Apart from waterproofing of basements, which people generally see as kind of floor slabs and retaining walls, we also indulge in buried roofs and podium decks, which often cover basements like a lid, if you like, or balconies and things like that, that are also ancillary to the basement. We look at flood resilience. Yeah, we'll see that flood resilience has an impact on below ground structures and waterproofing design in terms of climate change, surface water flooding, and what threats that poses to the integrity of a basement or a building. So these are all related disciplines. Brown gases. I was just saying to Rosemary before we started that we deal with basements in brownfield sites or otherwise contaminated, or land that is at risk of latent fuel spills, for example, or methane or CO2, you know, from industrial processes and whatnot. So we have to talk about integrating waterproofing with ground gas protection, which can get a little tricky, to be honest. Well, within our competence, we operate a network of what we call Delta registered installers. So these are high-level specialist contractors that just practice waterproofing installations, and we work with them hand in hand in order to make sure that the design solution is integrated with their perception of what's required, but also in terms of the product installations. And we train them. We offer loads and loads of training courses on waterproofing product installation and also waterproofing design. So we're very, very much embedded in ensuring that integrated solutions are achieved which comply with standards. We practice sustainable manufacturing practices, as you'd imagine, in terms of looking after the environment. We take all our products, so we literally get them and we put them through stress tests, if you like, and we see what works with what best and what renders are more compatible with meshed membranes and all sorts of things like that. So we're very practical in testing. BBA certifications, as you'd expect, for all our products, and we look at life cycle of systems. So products that are installed need to be capable of supporting the requirements for the life cycle of the building. So we go well in excess of the 10 years or 30-year type product guarantees, and we accelerate age test products to 60 years or so. So we're very, very cautious and risk averse in terms of making sure the products are going to do the job for the lifetime of the building. So that will make sense, I hope. Sustainable practices, I've mentioned recycled materials we use virgin HDPE, not recycled HDPE. For our membranes, various R&D initiatives that we have, and product data sheets, material safety data sheets, all the sort of stuff we'd expect really to comply with health and safety. So having said that, just remember that we're generally a good, hard-working bunch of people who just want to help, and that's it. We're very accessible, as I'm sure you'll find if and when you start to work with us. Now, the thrust of the presentation really revolves around a key standard called BS 8102. This was originally written in 1990. It was updated in 2009, and it's been updated again to a 2022 version. So this standard evolves in accordance with new construction techniques and new products and things like that. So it's all up to date. And what does this mean for waterproofing? Well, it's like the Bible, yeah. It's like the Holy Bible the waterproofing. So every decision I make, every bit of advice I give relates back to that standard. It's so important, can't overstate how crucial it is that all the advice that I give relates back to this standard. It's an excellent standard. It does give room for interpretation, as all standards do. They're best practice documents, but everything I do relates back to this. And that is really like a quality control procedure for design. So what does it actually have in it? Well, I like to see BS 8102 a bit like a climbing frame or some kind of, rigid metal framework, because I hang all my decisions on this framework that is the standard. And I'll just give you an insight into what's in it and what I need to consider when I'm doing a waterproofing design. So I need to consider structure. Okay, so we've got in situ reinforced concrete, precast concrete panels. We've got sheet piles, contiguous secant piles. We've got ground beams, raft slabs, strip footings. We've got all these components that make a building, and I need to assess how water resistant the structure is in its own right. In some cases, how appropriate it is for the application of certain types of products, okay, which are compatible with different structures. So that's the structure. Everything starts with the structure. Water table classification. I need to look at site investigation reports, the history of the building, if it's an existing building, things like that, to understand what the risk level, if you like, or the threat level is in terms of water ingress. The water table classification is important. We have high water tables, we have low water tables, we have variable water tables. All water tables can change, okay, depending on the time of year, and also, as I've alluded to, in terms of climate change. So I need to think about that, because if we're going to build a basement and it's a new build, we're going to dig a big hole and we're going to build the basement and we're going to backfill it. But what happens if we dig that big hole and the water table's 2 feet below the surface of the soil? Well, we're trying to build in a duck pond, aren't we? So it's important to consider that kind of thing as well. Water table classification. Topography. Is the basement on the top of a hill? Is it a chalk soil, which is free draining? Or is it in the bottom of a valley or on the side of a hill? Is it clay soil, which will enable surface water to track along the top of it and hit the basement? So I need to think about that and how it's orientated and angled. Contaminants, methane, radon, CO2, VOCs, volatile organic compounds, contamination. I need to think about all that, and that is generally thrown up in the site investigation reports or the geotechnical reports, which are normally part of the planning condition of the basement. Soil gases, I've talked about. What's the building going to be used for? Is it a car park? Is it a plant room? Is it a high-spec hotel? Is it a house? The use of the building is very important, because, as we'll see, there are grades of environment in BS 8102, grades 1, 2 and 3, which have an impact on how we're going to waterproof it. Are damp patches acceptable? Can the waterproofing system be accessed for repair after it's been installed? What are the implications of minimal water ingress into various environments? So I need to think about building use. Environmental grades 1, 2 or 3. Grade 1, generally a car park where seepage may be tolerable. Grade 2, a plant room where those damp patches may be okay and not affect the use. Or is it grade 3? Is it an occupied environment like I'm in now? And what are the implications of any failures or water ingress into that? So I need to think about that as well. Forms of waterproofing, type A, B or C. We'll go into this in more detail, but generally speaking, type A waterproofing is a barrier that's applied separately to the structure to keep water out. So tanking, I guess it would be known as, type B is when the structure itself provides a waterproofing system. So think in terms of in situ reinforced concrete with an additive in, water bars, that kind of thing. Or is it type C, which is a passive system really, where we essentially line the internal faces of the structure with studded membranes which act to intercept and guide any minimal water ingress to a planned system of serviceable drainage and thence to sump pump systems and things like that. So these are in my armoury. Yeah, I can choose type A, B or C for my systems to protect a certain grade of environment, or I can combine these systems to minimise risk, as far as possible to the nth degree. so that it becomes a safer solution if I'm protecting a high standard environment. So we'll look at combined protection, which is quite a big feature, especially when it comes to warranty providers like NHBC, LABC, ICW, all these insurance companies that now insist on combined protection for grade 3 environments. Consequences, defects. So when I design a system, I almost have to think what can go wrong, who can damage what gets covered up, what's the time of year, what's the temperature going to be, will the product be appropriate to be installed at 2 degrees C, things like that. So that can all engender defects on site. Site conditions are less than perfect. Yeah, I'm sure we'll all agree. There's plenty of scope for less than adequate workmanship, damage, people putting corners, all sorts of things. So I need to factor this into the design to try and make sure that they're designed out, risk is designed out as much as possible, which leads on to accessibility for repair or maintenance. Once a system's installed, can it be repaired if there's a defect? Well, if the answer is no, then I generally combine systems so that the effects of that defect are taken up, if you like, or dealt with by a secondary system. It's all risk aversion, which also leads to the scope for testing during construction. Can we test waterproofing systems during construction? Generally, no, because we can't flood the site for a couple of weeks while we all wait to see if the basement's going to leak before we backfill it. So that can lead to the choice of combined systems to reduce risk, etc., etc. We'll come on to all of these in a bit more detail. Planned future maintenance. Does the system need to be maintained in any way? If it's a drainage-based system, such as a Type C cavity drainage system, then certainly it does, because the pumps and channels need to be serviced at least annually. So that's just an example of planned future maintenance and the importance of handing over in documentation to the client, the importance of having the system maintained and what period of time and who to contact in order to do it. So there's a lot there, isn't there? There's a lot there to consider. Sometimes I wonder how I manage it, to be honest. But you do get into the flow, and I've been doing this for a very long time. So that's all the considerations in the S8102 2022, the Bible of waterproofing. It's been updated recently, as I said. This is the new version now. A few key changes between the 2009 and the 2022 version. The new version talks about water ingress, so the previous one had an emphasis on groundwater. The new version now talks also about just water and the possibility that it can come to bear against any part of the structure that is at or below ground level. Okay, so this alludes to surface water flooding now, as you'd expect with climate change and the Somerset levels and London flooding, the year before last and things like that, and flash flooding, overwhelming of drainage systems and overland flow. So now we're asked to consider taking our basement systems to a minimum of 150 mil above ground level as a kind of risk assessment, if you like, should surface water flood occur. So that's an important change. Less emphasis on groundwater, more emphasis on just water from any source, because we don't want our basements to end up like this, okay? We don't want water barreling down the stairs, having come through the front door and flooding the basement, because what is a basement? Well, it's a below ground sump, isn't it? Basically, it's an area that's just asking to be filled with water. And how do we get rid of the water when it's in there? Well, when it's done its damage and pumps it out, the answer is really we strip it out and we start again, don't we? So it kind of ties in with flood resilience and this new emphasis on taking waterproofing above ground level to provide some kind of protection should an overland flow occur. And that's the standard for flood resilience. So that's referenced in the S8102 2022, and it wasn't referenced in the previous standard. So that's important, part of our risk assessment. If we want to check if a basement site is going to be in a flood affected area, we can go on to DEFRA websites and various government websites, and we can look at maps. We can see, is the site got a history of flooding? Is there a flood risk? And we can factor that into the design, can't we? As part of our due diligence, looking at the site conditions. There used to be a form of waterproofing, a Type A barrier system that are called sandwiched waterproofing, okay, which was within the structure. So it was basically, a sheet membrane which was applied to the inside of the structure and kind of stuck on and then backfilled, backloaded an internal wall and maybe a reinforced concrete slab on the inside, which kind of sandwiched the waterproofing. That's now gone because it was a bad idea to start with, because it was pushed off when water came through the structure inevitably. Inconvenient things like wall ties were kind of conveniently not thought about with sandwich waterproofing, because it's a penetration, isn't it? Every wall tie is a penetration. The fact that pressure, when it comes through a structure and comes through what we call the negative side, is very powerful. It can force membranes off, and that kind of system is inaccessible for repair or maintenance, and there's no scope for testing during construction, is there? So there were lots and lots of failures with sandwich waterproofing. No one could repair it. No one knew where it had failed. They couldn't take the internal block leaf down because to access it, because the building would have fallen down. So it was just a bad idea. Okay, so that's gone. So that's really important. The grades of environment I talked about, and we'll talk about these a little bit now. We've got 3 grades, performance levels, if you like. So we've got car parking and plant rooms, where some seepage and damp areas are tolerable. The space remains fit for purpose, does it not? If there's a bit of a damp patch under the Tesco's car park, not really a problem, provided that there's localised drainage, eco drains and gullies and whatnot, provided to deal with any ingress at the edges. And we've got grade 2, plant rooms, workshops, that kind of thing, where no actual physical water is allowed in to flow down the walls and across the floor, but it's not the end of the world if there's a damp area, and we might need to ventilate it to discourage formation of condensation, for example. It can also be a source of dampness. And then we've got grade 3, which is basically what I'm sat in now and what you're all no doubt sat in, which is an office environment, a domestic environment where no water penetration at all is acceptable, no damp patches, no liquid water, and we need to heat it and ventilate it to manage the environment so we don't get condensation and mold growth, and things like that. So those are the 3 grades. The new standard, the 2022 standard, has introduced something called grade 1B, which is a little bit confusing, I think, because it says that we can have damp patches from water penetrating the structure, but we can't have any seepage. So if you can design me a structure which allows water to come through it, only emerge so slowly that it evaporates faster than it can come through as a liquid and thereby forms a damp patch, then I'll give you £1 million, because I don't think that's really feasible. But nevertheless, without trying to rubbish the inclusion of grade 1B, it does point at an attempt to crack down, if you like, on these grades of environment, and just to see what all the possibilities can be. So those are the grades of environment. It recommends on podium decks and buried roofs a fall of 1 in 80. Okay, so previously with buried roofs, podium decks, things over basements basically, which get rained on, there wasn't a requirement for a fall, but now people recognise the importance of shedding water to a decent drainage system so that undue pressure isn't placed on the waterproofing system by ponding. Okay, and also you can see there that's over a precast concrete unit, planks basically, hollow core planks, which are not appropriate to be waterproofed on their own. We need some kind of cohesive, flat substrate to apply waterproofing products to, because structures like that are subject to deflection and movement as well. So we don't want that happening. So that's a fall of 1 in 80 that's now recommended. This is a flat deck in the Cotswolds, which leaked, obviously. So we don't have that anymore, because what we had on there was significant ponding, which put the waterproofing system under undue stress, which led to leakage in the long term as the products gradually degraded, because they weren't designed as pond liners. They were designed to deflect water to a drainage system. So we don't have flat decks anymore, no such thing. A lot of basements in London and big cities, particularly big new ones, the Shard, things like that. These have multi-level basements. So consideration has been given to how we deal with water ingress in multi-level basements. So in other words, how do we get water that's come through the structure into a cavity drainage system, which is what you can see here. You can see the studded membrane, can't you, on the inside. How do we get that down through the intermediate floors and into a sump and pump system so it can be pumped out? So there's various ways of doing it. This is basically pipes that provide drainage continuity through in situ concrete floors. So there is more consideration now given to multi-level basements and various techniques. That's not the only way of doing it. It's just a good example. So multi-level basements, cavity drainage systems which manage water ingress behind membranes and direct it into channels and pump it away. Basically, that's now been highlighted as requiring a battery backup and a dual sump pump. So a dual sump pump is basically a pump with two pumps in it, on the basis that if one breaks down or there's a fault with it, the other one will trigger and the basement won't flood. And in doing so, it will activate an alarm. And if there's a power cut, there is a battery backup to run the pumps. When the power cuts happen, maybe in the middle of an electrical storm, for example, and when it's raining the hardest. So battery backups, dual sump systems, and high water alarms are now recommended in the standard. Makes a lot of sense to me. Service penetrations. So in our new build basement, there's a propensity for follow-on trades to come along and put holes through your beautiful waterproofing system because they forgot to put a duct in or something like that, you know, and you'll never know about it until the building leaks. So where we do know about service penetrations that are going to go through, we use things like puddle flanges, and we use various sealants, and even sealants that can seal around little pipes within big pipes, you know, which can be quite a problem, and various ways of dealing with service penetrations. So those have been highlighted because they've caused a lot of problems in the past. We operate a network of Delta registered installers who we work with and train, which I've talked about before. Now there's emphasis on that in the British standard. So emphasis on the use of properly trained, skilled, certified, experienced and insured specialist contractors for waterproofing installations. No disrespect to general builders and main contractors, but this is not what they do all day long, is it? You know, install waterproofing systems. And waterproofing systems have to be installed to a very high standard to be effective. So we try to take that out of the realm of general builders and tradesmen and put it firmly in the realm of specialist installers for everybody's benefit. And this is now emphasised in the new standard. So that makes a lot of sense. I've talked about brown gases a little bit, haven't I? And contaminated land and brownfield sites. So there's more emphasis now on linking brown gas protection with waterproofing, okay, hazards on site due to contamination. And there is a code of practice called BS 8485, which has been in circulation for a long time now, quite a thick document, quite a complicated document, which is the code of practice for design of protective measures against methane and carbon dioxide in new buildings. Okay, so I need to reference that as well. And BRE 211, which is the go-to radon standard. I need to factor that in as well. If it's in, you know, Cornwall or Aberdeenshire or the Peak District or somewhere like that, which is perceived as a radon affected area, we need to design in either basic radon protection or full radon protection. This isn't a radon seminar, so I won't go into what the kind of differences are, etc. But it impacts on the waterproofing system, okay? Because if water can get in, then radon can get in, because water is a great carrier of radon gas. Okay? So various things that I need to do depending on contamination for potential for radon as well. This is out of BR 211, the radon standard. So I'll just show you these. So there are UK radon maps in there which show the risk due to radon contamination, basically, and on the kind of rock, you know, and the decomposition of the radioactive element, which is what radon is, the alpha particles. So if it was in Cornwall, then I'd be factoring in radon protection, because that's a high risk area and it specifies a level of protection for radon. So you thought this was all about waterproofing, didn't you? Well, it is, but there's a lot more that needs to go into the considerations, not just keeping the water out and achieving a certain grade of environment. There's all sorts of other risk factors that need to be integrated with the waterproofing design. Delta actually makes a membrane, a cavity drainage membrane, you can see there, which is certified as a gas resistant membrane under BS 8485, which is a unique product. So as you can probably imagine, this helps enormously with combining waterproofing protection with protection against methane, CO2, radon, and VOCs. So that's just a unique product that Delta have. And there is some more emphasis on fire safety, as you'd expect with regard to the Grenfell Tower disaster, compartmentalisation in basements, protected routes of escape. In support of that, we've actually developed a fire retardant membrane. So on the left, you can see a standard HDPE cavity drainage membrane, which is it's flammable, that supports the propagation of toxic fumes and whatnot. And on the right, you can see Delta MS Fire cavity drainage membrane, which just melts basically, so it doesn't actually burst into flames. So that's a unique product that Delta have as well. And there is more in the new standard in terms of updates, but I don't need to go into. I mean, that's far more than enough. So yeah, going back to grades of waterproofing, one of the first questions I ask is, what's the basement going to be used for? And if it's a car park, I'll make certain decisions. And if it's a high spec office block or something, then I'll make other decisions. So just to remind you, grade 1, seepage and damp areas are tolerable. So that could be a car park. Grade 1B, we've talked about that. Grade 2, no seepage is acceptable, but damp areas are tolerable. And grade 3, no water ingress whatsoever of any kind, no damp areas, not acceptable. And we manage the internal environment with appropriate heating, ventilation, dehumidification, whatever's needed to stop condensation happening. So we have a dry environment at grade 3. So that's the first question. In order to achieve grades of environment, like I say, we have type A barrier protection, so a separate membrane that's applied to the structure to keep water out. We have type B protection, which is generally reinforced concrete with an additive in it, or concrete structures designed to be SEN 1992. And type C, we have a drained protection system which manages seepage through either of the aforementioned systems, because no installation under site conditions is going to be perfect, because that's life, yeah, and damage and issues of temperature and follow-on trades and all that kind of thing. And a type C protection, what it does, it's like a sort of, a safe passive system, if you like, that says, okay, if there's any defects and there is seepage and we can't rectify the seepage and we don't know where it's come from, we're going to put in a passive system that's going to direct that seepage to a maintainable drainage system and maybe a sump pump, or out to daylight if it's a house into a hillside or something. So it's really the only system, a type C system, that doesn't rely on perfect workmanship to work, because it's passive and directing water. It's not taking any pressure, blocking anything out. So it's a very effective system to line the internal faces of buildings with, to manage seepage or defects through structures due to maybe defects in installation or issues, that have occurred on site that we didn't know about. So it's a really good insurance policy in a way, because like BS 8102 says, the ideal waterproofing solution would be defect free. Of course it would. However, it should be noted that product or workmanship defects may occur, resulting in the required internal environment not being achieved. Most common defects are defects owing to design, because shock horror, not even waterproofing designers are perfect all the time. Defects owing to poor workmanship, pretty common, I'd say. Inappropriate use of materials being used. Some contractors unfortunately apply inappropriate products to inappropriate substrates, so not compatible. And defects caused by follow-on trades and site operations. So a lot can go wrong. We need to factor that into the waterproofing design. We live in the real world. This is my favourite defect, by the way, just thought I'd throw this in. This is a basement in the Midlands with a podium deck above it, like a big buried roof that cars park on. And what we can see here is a shot from within the basement. And what we're looking at is a waterfall in the middle of the basement, isn't it? Which is a bit of a shocking scenario. You wouldn't really want this in the middle of your living room. So why did that waterfall appear in the middle of the basement? Well, it's obviously rainwater, which has come through. Why has it come through? And why has it come through there? Well, there's your defect. Okay, so you go to the edge the deck. We exposed the waterproofing to see what was going on, and we can see at the edge of the deck there's a cheap grade insulation which was used, which is kind of compressible and not appropriate to support a waterproofing product. Okay, there was a much more robust insulation specified, so that's corner cutting. That's the client trying to get value. We'll just put this stuff in, it's good. Well, it's not. We look at the waterproofing system on it. It's not continuous over the edge of that deck, is it? Over the top of the retaining wall, there's a big slot there. Okay, the top of the retaining wall itself should have been smooth, a bit like a smooth, like elephant's backside, if you like concrete haunch, to allow the waterproofing system to transition over the top of it and down the outside of the wall. Is it? No, it's a dog's dinner. Okay, so there's problems there. And what happens is that rainwater falls on the deck, it gets onto the waterproofing system, it falls down, goes down the slot, forms basically a little river down there, and that gets into the structure, which is precast hollow core units with hollow pores, goes along the hollow pores, and it empties out like a waterfall. So those are the defects that led to that failure. So less than adequate workmanship, poor specification of the insulation, value engineering by the client, poor structural formation, if you like, of the retaining wall. And all these factors led to a disaster. Okay, so that's my favourite defects. We put that right in the end by using 2 waterproofing systems and substituting the insulation, and we'll talk about that later when I talk about open decks. So that's a defect. Lots of them. Water tables, okay. So in BS 8102, it says, is the water table low? Is it high? Is it variable? Well, sometimes you just don't know, okay, especially if it's an existing building, because we don't always have site investigations and trial holes and geotechnical reports. But the fact of the matter is, whether it's low, high or variable is almost immaterial, because water tables change. Okay, they're higher in winter normally, they're lower in summer. If you build an office block next to the building, that could displace water in the ground, create an artificially high water table where there wasn't one before. So generally speaking, just assume that the water table will reach to the full height of the basement at some point during its lifetime, because it's variable, it can change. We're not weather gods. We can't predict what's going to happen underground, how much water there'll be, climate change, flooding, all sorts of things, yeah? So we just assume that the water table is going to be to the full height of the basement. We'll come on to different types of waterproofing now. So we've talked about type A, B, and C. Type A, barrier protection. Okay, so this is a membrane, in this case, that's applied under the slab of the basement, or the basement slab is poured. And you can see these guys treading all over this white membrane, putting bits of reinforcement on it. They've probably got stones in the hobnail boots, So what we're getting there is damage, isn't it, potentially? So although the membrane was perfectly installed, these follow-on trades are damaging the membrane. So here we have, it's an apartment block in Paisley, which is basically not far from Glasgow. We have a pre-applied fully bonded membrane here. And if we could zero in on that membrane, we'd see it's got a fleece on the top of it, which is going to fully bond to the concrete. So if there is a defect, then the defect will stay isolated to the point at which the defect occurred, instead of tracking, between the structure and the membrane and finding a construction joint or something to come through. And that's an example of a pre-applied fully bonded type A membrane. It's the same membrane on the external face of some sheet steel piles. The concrete will be poured up against this and it will fully bond to the concrete. This is actually a car park in Manchester on the left. On the right, we've got a type A barrier, which is a trowel applied one. It's a polymodified bitumen with some reinforcement mesh in it. So you can see there the reinforcement mesh poking out and the land drain to depressurize the groundwater, which can build up against it. So that's a troweled or post-applied system, if you like, on after the structure has been done. So these are all type A. We can't put type A products on the outside of the building because it's existing. That's a very good argument. We can't dig it out of the ground and waterproof it on the outside. We need products that are going to be of withstanding pressure that comes through the existing structure. So now we're into type A cement-based slurries, okay, crystalline slurries, multi-coat renders, repair mortars, things like that. so that we can do what we call lock down the structure from the inside using these products which grow in, if you like, crystallize within the pores of the concrete, brickwork, masonry, whatever it is. So they're type A systems on the negative face, the internal face. The outside face of the basement is called the positive face. That's where we have membranes. On the inside, we're always going to use cement-based products that grow into the structure and become monolithic with it, yeah? So those are type A products on the inside. Type B construction is integrally watertight structures. So 9 times out of 10, these are in situ reinforced concrete structures with water bars or hydrophilic strips, in the joints, because the joints are the weak points. So that's where the structure itself is providing the waterproofing, or the waterproofing in combination with another system, because I've already talked about combining systems to lower risk, depending on the grade of environment. So that's a hydrophilic strip on the left, expands on contact with water, seals the joint. The one on the right is a water bar, various types. This is a fin of metal with like an active slurry on it, and that's there to stop the water coming through the joint. And then type C cavity drainage systems. These are the studded membranes which manage water and direct it behind the membranes with no pressure, passively to a drainage system, a sump and pump system. And here you can see the internal faces of the building have been membraned. You can see this perimeter channel, can't you, which forms a low spot, a bit like a moat, secret moat around the wall and floor joint of that building, so that water that comes in behind the wall membrane or under the floor membrane will migrate its way, push its way across, as water forms what we call its own hydraulic gradient. It pushes its way flat, if you like, to find a low spot, and the channel is the low spot, and it's pumped away. And that's a nice slide, that just showing what a cavity drainage system is. Very simple, doesn't rely on perfect workmanship, can be tested during construction because we can flood test the channels and make sure it's going to drain effectively. It's the only system that really can be tested properly during construction, and it's a nice, safe, passive system to cope with seepage. These are the drainage channels that are part of a cavity drainage system, a type C system, and we can see here that you've got inspection ports, okay, so that they can be accessed, inspected once a year and flushed out if necessary. So it's a maintainable drainage system linked with a sump and pump, or with a gravity drainage outlet above ground if there's a house into a hillside, that kind of thing. So these are all perimeter channels and cavity drainage membranes. Look at the inspection port on the left-hand photograph. You can see the little white pipe sticking up. So we put these at key changes in direction. These will come up through the floor screeds and finishes, and they'll be accessible so we can peer down, check if there's any free lime, blockages in the channels, push them out gently if we want to, make sure they flow to the sump pump and it's all working properly. It's a maintainable system, passive system, doesn't block water out, isn't under pressure, doesn't need perfect workmanship to work, needs a good standard of workmanship to work, but not perfect. So it's a forgiving system, and it's a great system as an insurance policy to back up other systems. This is just a quick illustration of a cavity. A little bit over it. So here we've got structure, and we're applying a cavity drainage membrane to the internal face. Here we're through and direct it safely to a maintainable cavity drainage system, to channels and to sump pumps. So now we're drilling these 10 or 11 millimeter holes with point fitting system to make structure using seal hollows. This is what's holding it to the wall. So you can run it around the wood. It's nicely to the stud. This is the drainage channel going in. Around the perimeter. That's the floor membrane. Floor membrane is general. Need to be able to have bonding without membrane overwhelming. And then we have our finish. This is a drainage system. Various finishes are possible. So the buttons there through into the sealed wood. Hollow. We have back insulated plasterboard can be applied buttons if we want. Timber frame and foot of it, line system or a timber foot, like that, and then we So,
Hi, Michael.
line.
Sorry, we're losing a little bit of sound. I think I'm not sure if it's at your end. The connectivity, it's getting a little bit. I'm not sure if it's at our end or yours.
It might be the animation.
Right. Okay. That's probably what it is.
Yeah.
Okay. Sorry. Carry on.
Will be, yeah. It's just that we'll have to deal. It's a technical gremlin, I'm afraid.
Okay.
It's
No problem.
pretty
Carry on.
self-explanatory. Yeah, it's fine. So this is block work that's being tied in. The wall ties are screwed into the seal books. This will be over in a minute. So this is a mesh membrane. So we have a cavity drainage membrane that we add plasterboard to, if we wish, or we can render it. I'll skip a little bit if it's been a bit of a pain. There's a lot of plugs needed to put a mesh membrane to the wall because we need to take out the weight of the plasterboard. Then we've got water coming through. And that's how it works, yeah. Simples, manages seepage. Nice, simple system. Probably my favourite waterproofing system there. So that's fine. Okay, so can you hear me now, Rosemary? Is that okay?
That's much better. Yes, thank you, Michael. Yeah.
Yeah, sorry about that. So the audio on the animation conflicted with what we're trying to achieve. All right. So cavity drainage systems, all right, brilliant. The enemy of cavity drainage systems is free lime, right? So anything calcium carbonate within the structure, free lime, can dissolve when water comes through it, and it can harden again into this lime scale, okay, which can fill channels and block sump pumps up and cause problems for cavity drainage systems. So when we put a cavity drainage system in, we always prime the substrate with an anti-lime primer. In this case, it's called polysil. And what this does, it stands for polysilicates, yeah, and it forms a silica gel, if you like, within the surface of the substrate, which locks it down. Okay, so it stops free lime coming through the structure and blocking up the cavity drainage system, a bit like Calgon or whatever in your kettle. Yeah, this is the equivalent for basement. So we can inhibit free lime, and we can therefore stop the systems blocking up. And you can see a block channel on the bottom right, and you can see a sump discharge which is blocked with free lime. So we need to lock down the structure when we use cavity drainage systems to prevent free lime ingress. Okay, and that's why maintainable systems are designed with inspection ports, so we can maintain them. And if there is any buildup of silt, free lime, or anything else in the channels, we can maintain the channels. We talked about a dual sump and pump station being included as part of BS 8102 2022. So this has always got two pumps in. There's always a high water alarm and a battery backup system. And these sump chambers are where cavity drainage systems discharge into. Okay, so we're factoring in safety. We can also get rid of foul water. Not every basement is conveniently located to a sewer that's 4 meters down or we can connect into, and we wouldn't want to anyway, because if the sewer backwashes and becomes surcharged, we don't want our basement filling with effluent from the sewer, do we? So we use foul pumps in conjunction with groundwater pumps, but we always keep the system separate for obvious reasons. For storage, WCs, showers, whatever is down in your basement, really. And there are certain storage regulations of 150 litres per person for 24 hours. We can size pumps and specify pumps, foul pumps, in accordance with how many people are in the building, and how many toilets and sinks, etc. there are. So that's just not waterproofing exactly, but it is important for basements because we need to be able to have pumps that can get rid of foul waste as well as groundwater. We talked about Power Max and Alert Max. So these are battery backups for pumps and high water alarms for pumps as well. And alarms these days are not just a beeping thing in the basement. They're sending messages, in terms of how the pumps are performing and how many times they activate and is the motor still efficient, and things like that. So it's very, very high level monitoring of performance, so we can predict a failure if there's going to be one before it happens from the data that the alarm is sending to the servicing engineer. So so predictive maintenance. And now we're going to talk about combining protection. So A, B, and C, we combine systems to reduce risk. Okay, so A and B, A and C, B and C, A, B, and C. I've got a job on at the moment where 3 waterproofing systems are being used on a particularly wet site. And these are very important principles of combining protection to lower risk. So in BS 8102, it says consideration should be given to the use of combined protection, where in a single system, the risks are deemed to be high. The consequences of failure to achieve the required internal environment are too high. So where are the consequences of defects high? Yeah, where would the worst case scenario be for a leak? In a grade 3 environment, wouldn't it? So with grade 3 environments, which are occupied environments, we always combine systems on the basis that no system is defect free. These things can't always be tested during construction, can't be accessed for repair or maintenance once installed. So we can't put it right. So we combine systems to lower risk. So I hope that makes sense, because it's very important. So here's a job in a place called Conley near Bradford. Got a Type A external on the right for this new house into a hillside. You can see there's the barrier. Are we going to rely on the barrier on its own? Not on your Nelly. Okay, we're going to put a Type C system on the inside so that if there are defects in the barrier and water gets in, then we can catch the seepage and we can drain it away and get rid of it. So that's a brilliant example of a combined system to lower risk in a house. There's your pre-applied membrane under the slab in that particular job. This is the job a bit later, the Type A going in on the outside and the Type C on the inside. In this case, in the cavity, so we can tie in the inner leaf using wall ties that are screwed into the plugs, basically. So Type A and Type C there. Type B and Type C. The Type B concrete, the waterproof concrete is there. Is it watertight? Well, not really, because you can see the leaks and you can see the aggregate that's exposed because it's not been compacted properly, so less than adequate workmanship. What do we do with this? Well, the first waterproofing system has partially failed, so we fix the defects in it. So we stop the seepage using injection techniques or slurries and whatever. And then we've got a Type C system, okay, which you can see the membrane for coming in from the left. So managing the scope for defects during construction with combined systems. Underpinning, okay, underpinning is a bit of a nightmare. Basements, very common with increasing headroom, but very, very permeable to groundwater ingress through all the multiplicity of joints that you can see there. So what do we do with underpinning? Well, we lock it down using Type A cement-based products, okay, which is what these guys are doing there. And then we can back that system up, because we can't rely on it 100% with a Type C system. So those are 3 examples of different combinations of combined system. Underpinning, a very quick illustration now with no sound on it, so hopefully you can hear me. Dry pack joint, we have a repair mortar plus pointing. That's an expanding repair mortar. We've got a water bar, got a slab going in, got a fillet of repair mortar there. We've got defects in the underpinning. We address those using leak sealing products to lock it down. We've got an anti-lime primer going on. Remember what I said about the free lime for cavity drainage systems. We've got our cement-based slurry as our Type A system. We've got a channel there if we want a channel for drainage or modular drainage there, getting rid of the water, and we've got a Type C system going in. Combination of systems, how to deal with underpinning there. Quite a nice illustration. Warranty providers. We deal with a lot of jobs that are new build houses, in particular, and HBCs involved, LABC, Premier Guarantees. They've all got technical standards which broadly align with BS 8102. So BS 8102 says that a waterproofing specialist should be included as part of the design team. That's what an HBC say as well. So we align there. An HBC are saying that they won't warranty any basement which is more than 600 millimeters deep unless there are combined systems of waterproofing installed. What do we say? Well, in BS 8102, we manage risk in grade 3 environments by combining waterproofing systems. So we align there as well. LABC saying exactly the same thing. Combined protection by the installation of 2 forms of waterproofing would substantially lower the risk and may be necessary where the consequences of failure are great. Wherever the consequences of failure are great, grade 3 environment, okay, an occupied environment where no water ingress or damp patches are allowed. So we combine systems, and that's the LABC technical manual talking about how to combine systems and educating their surveyors on what good practice is. Just a few details now. I'll wrap up in about five minutes or so. These are all on our website. So how do we manage internal load-bearing walls with Type C systems? Well, the internal cavity drainage membranes need to stop and start, don't they? Because we don't build structural walls on cavity drainage membranes as a rule. So we have the internal wall transferring its load straight down to the slab, and we have what we call weep holes or mouse runs in the wall so that water can get from one side of the wall to the other, yeah, through the membrane, through the wall, and access the drainage channel, wherever that might be. We simply connect the membranes through the wall using a wide profile damp course, which is taken over the lower block there. So that's continuity of a Type C system through an internal load-bearing wall. If it's an in situ concrete load-bearing wall which divides the basement, well, instead of using a physical DPC, we'd use a crystalline slurry, which is your figure 1 there, to provide the waterproofing continuity through that wall, because it's acting like a DPC, isn't it? Because we've got a capillary damp problem potentially coming up the wall of rising damp. So the slurry there is suitable to go within a concrete construction joint, but it's also adept at stopping water rising. So we've got our continuity there. That's the locking down the structure underpinning detail. So we can see the dry pack, number 2, repair mortar, number 3, crystalline slurry, Type A system, number 4, and number 6 is your cavity drainage system. Lift pits, the bane of my life. So lift pits, always the lowest part of the building. We can't line them with cavity drainage systems for obvious reasons, because of the plant and fuel and all the fixings and stuff like that. So we have a Type A system on the outside, a reinforced concrete structure with water bars in it, and we have another Type A system on the inside. Okay, so we're really kind of going to town on levels of protection. So 2 waterproofing membranes and a structure which is integrally water resistant as well. We can't put sumps and pumps in lift pits. So don't really specify lift pits that are built from block work, because that's not very good, because that's very permeable and it's not great for reapplied fully bonded membranes. Try and specify lift pits in reinforced concrete would be my honest advice, and it'll save everyone a lot of headaches. If we can't cut a chase or form a chase for a cavity drainage system in a slab, then we can put a 50mm screed on top of it to form that load point around the perimeter. And then we can put our drainage channel into that. So it eliminates the need to cut or form a drainage channel. And that's very useful in retrofit sometimes, where we can't cut chases in slabs, because we'll compromise the structure. So that's a different approach to forming a drainage channel. In warehouses or industrial buildings that are slightly into hillsides, you know, because they're quite long and sometimes the site rises at one end or the other, we can use a combination of Type C and structure to create a usable concrete floor, a power floated floor, without the need to line over it using cavity drainage membranes and then put another slab on top of that. So we kind of get like a hybrid Type C system where we manage water ingress at the edges. We use the concrete structure and slab and or a membrane under it to preserve the usefulness of the slab for driving forklift trucks over it and things like that. And we can do things like resins, you know, like a resin floor coating on top of the slab. So we deal with pressure at the edges where 99% of water comes in and the walls, but we maintain a usable slab for industrial purposes. This is a modular system, so where we don't have a channel, we can put a network of 110mm pipes with upturns through the slab, which all connect below the slab and flow to a sump and pump system. So think about a shower tray on a huge scale with lots of plug holes in it, okay, and then lining over the shower tray with a cavity drainage membrane. And that's pretty much what a modular system is. And this is a flood test on a modular system. So this is one of the drainage upturns after the slab's been formed. We're flood testing it. Why? So that we can identify any low areas that might pond to more than a centimetre, you know, potentially float a cavity drainage membrane if it's too deep. And we can test the drainage system so we know it's going to work before we close it in. And that really aligns nicely with the S8102, doesn't it? Which says that you should take into account the scope for testing during construction. A really important video there. House into a hillside, so 2 systems on the retaining wall. You can see there, type A on the outside and type C in the cavity. We've got a suspended floor over a void there, so there's no pressure coming in on the structure, but from underneath. But we need to make sure that that drainage space under the beam and block floor, which is usually 150 mil with a blinding layer on it, remains free from build-up of water. So we need to make sure that drains, normally via gravity, via a maintainable land drain or something like that. So that's a house into a hillside. That's the real life photo of that. You can see the 2 systems, type A on the outside, type C on the inside. So I hope that, and the type C drains into the subfloor void, and that's made drainable, maintainable as well. So that's a good detail. And that's just a slide, just talking about our registered installers again, so that we always have experts in our systems, installing and trained experts to do it. So that's the most of the presentation. So I'm a bit of a curry fan, yeah. So I like lamb tikka madras. So I like to look at waterproofing a bit like a curry. Yeah, it's all prepared right, thought about. You're following a list of ingredients, recipe, and everything's cooked correctly, and it's all combined. It makes for a nice experience, But if you don't follow the recipe and you put the wrong ingredients in, and you don't mix it, heat it for long enough, and you end up with something not very nice. So it's like a curry, waterproofing. So linked with my my propensity for enjoying curries, and we've got that little analogy. So Rosemary, I've finished the presentation, most of it. There is a little bit about podium decks I could go into quickly, or we can call that a day because I've covered the content that I wanted to cover.
That's fabulous. Thanks, Michael. Yeah, I think we're just past 11. I've got a couple of questions, if that's okay.
Absolutely fine.
Yeah, I'm wondering from Keith Gold, are we still allowed to sandwich the waterproofing sandwich between the external insulation and the concrete? What is, in your opinion, the best insulation to put externally under basement floors / raft?
Yeah, you are. Yeah, that's not sandwich waterproofing. So putting insulation on the outside of the structure and then putting a layer of insulation in front of the waterproofing is perfectly fine, okay, because that's positively pressured, okay. So yeah, you've got your retaining wall, you've got your waterproofing layer on the outside of it, then you've got a layer of insulation on the outside of the waterproofing, and then you've probably got maybe a drainage membrane or something on the outside of the insulation to help depressurize it, if possible, into a land drain. Okay, so that's perfectly fine. The problem with sandwich waterproofing is that it's applied on the internal face of the main structure, okay, and it's applied normally as a sheet membrane, which is bonded using an adhesive, like a bitumen, basically, self-adhesive sheet membrane to the internal face. Now, membranes, generally speaking, are designed for the positive face of the structure. So they're on the outside being pushed on, right? We've got a membrane that we're sticking to the inside face of the structure, and that's going to be pushed off, isn't it? And the water's come through the structure. So that's negative side waterproofing using what should be a positive side self-adhesive sheet membrane. Now, the logic with sandwiched waterproofing was that it was fine to do that as long as we could put another structural element in front of the membrane on the inside and back grouts, okay? So we could fill the cavity between the internal leaf and the face of that membrane with grout to somehow force it back against the structure, yeah, to make it stay there without coming off. But it never works because you can never back grout to such a force that's going to equal the force of the water coming through, because you don't know how that's going to work. You've got things like wall ties and surface penetrations going into this membrane, this sandwiched membrane, if you like, that represent weaknesses. You can't test it during construction. And if a defect occurs in the building, it could have come in basically anywhere, and you'll never know, and you'll never be able to strip the internal structural element away to reveal the membrane and fix it, because the building would fall down, for obvious reasons. So it was really inappropriate use of sheet membranes in some kind of back grouted scenario, which was never successful and led to a lot of failures. So yeah, it's fine to put a positive membrane on the outside of a structure and put insulation, you know, on the outside of that, no problem, because that's doing what it should do. It's just this sandwich thing that was an issue.
Okay, thank you. And then the one from Richard asking if there's a definition of basement BS 8102, e.g. minimum depth of, the small differences between outside GL and FFL on around 600 to 700 millimeter. Would traditional methods of lapped polythene be acceptable?
Right. So yeah, it's a good question. So it's a judgment basically. So I guess the question is, what is a basement, and then when do we need waterproofing? Is a step in a slab a basement, or is a slab which is at ground level a basement because the base of it's below ground level, you know, things like that. So yeah, it's a good question. It's a bit of a debate. So the NHBC, right, to give some steer on this, define in their technical standards manual that 2 forms of waterproofing are required when the basement is basically below 600 millimeters below external ground level. Okay, so that's when their definition of a basement kicks in. Right now, with the new standard, there's what we've talked about is the possibility that there will be water ingress at or below ground level, isn't it? So now we're saying that the waterproofing has to extend to a minimum of 150 above ground level, which is basically DPC height, in case there's any water ingress, surface water flooding, that kind of thing at ground level, which could kind of go over the top of the waterproofing system. So that's another angle on what a basement is and where waterproofing is required. Now, for steps in slabs and things like that, I've seen a Barrett house flood, which was about 9 inches. The slab was 9 inches below ground level. Okay, because the water table was that high at certain times of year that it just came in. So my answer to that is that polythene and capillary dampness, damp proofing type membranes are acceptable at ground level, okay, because that's traditional construction, and that's what you normally expect a 1200 gauge visqueen for a house built on a flat site. Now, if you've got steps in that slab, there is the potential for a mini retaining wall to be formed. So I'd be putting something like a pre-applied fully bonded membrane under the slab instead of the traditional DPM. So I'd be putting a waterproofing membrane like that white stuff that I showed you, you know, the one under the Glasgow Paisley scheme with the hairy sort of surface to it, because that's a type A system. Okay, so yes, it'll provide damp proofing, but it'll also provide waterproofing protection. So if there was a step in the slab of however high, whether it's 200 mil, 600 mil, a meter or whatever, I'd be putting a waterproofing product under the slab instead of a traditional DPM. Because DPMs like visqueen, you know, 1200 gauge polythene, aren't designed to stop water coming in. Is there a possibility that water could come in? Yes. Why? Because we can't predict what the site conditions will be like, or when the heavy rainstorm is going to put temporary pressure on it. So yes, put a waterproofing product, a membrane, a type A membrane, under your slab if there's a step in it. Do we need 2 forms of waterproofing for every step in a slab? Well, no, because that would be ridiculous, wouldn't it? If we've got a 6-inch step in a slab on an otherwise flat site. So then we're looking at an HBC, for example, that say, yeah, well, we only need 2 forms of waterproofing if the step's 600 mil or more. Yeah, so that's a judgment call. So it is a judgment call. It does depend on site conditions. There is a risk that water will come through if there's a low point or a step in the slab. So I would go with a waterproofing system under the slab, or taking it 150 above external ground level at the edges. But for traditional flat site construction, unless there's an incredibly high water table, which will be shown during the site investigation, then you're going to go basically with, you know, your house builder's 1200 gauge polythene. So it's a case by case basis, and it's a judgment, and it's a risk assessment. But personally, yes, I would go for a type A fully bonded pre-applied membrane if there's a step or a change in level in a basement, or in a ground floor, if you like, of a more traditional construction. Does that answer the question, do you think? I mean, it's a...
I hope so. There's a couple more here, but I'm conscious of time because we're now 10 past 11. So it depends on your time, Michael, if you're okay for a couple more. Or
yeah, no problem.
Okay, I've got one from Tony. In your detail of type A and C, you show a delta profile, but it's not linked to the DPC. Should
Right.
not the type A be linked to the DPC to fully protect the outer leaf?
It depends, right? So if we've got a type A waterproofing system, and that's our only form of protection, right? Then there are ways of linking the type A membrane on the outside with the with the DPC at 150 above. Okay, so the waterproofing would go up the outside of the wall, it would cross into the cavity below the outer leaf of the building, and it would go up the inside leaf, if you like, of the cavity wall, and it would meet with the top of the cavity tray. So yes, absolutely, especially now because of the 150 above ground level thing in BS 8102 2022. So yeah, you should have continuity of the type A system on the outside to DPC level. So if you've seen a slide where it wasn't that, then the reason for that is because you've got a type C system on the inside, okay? Because the type C system can go all the way up the inside of the structure. It can go above where the ground level is externally, and it can tie in with the top of the cavity tray. Is that sufficient on its own? Well, it depends on the structure. So now we've got the surface water flooding consideration. I think that all type A systems should go up to DPC level by taking them into the cavity and up, yeah, on the inner leaf of the cavity wall. And that's a given, okay? And because we're combining protection in 9 times out of 10, you know, where it's a grade 3 environment, then we should also have the cavity drainage membrane coming up the internal face and also being linked to the top of the cavity tray. So yes, the answer to the question is, it's a good question. I think that the type A should go higher above external ground level by going into the cavity and up to the cavity tray. And I think that should be backed up with the type C system also going up the inside face and linking with the cavity tray. So you get the benefit of both systems to 150 above ground level. And that's my opinion.
Lovely. And then I've just got one last one here. Can you remind us of the registered installers arrangements? Are these installers that are trained in the tech and application of your products? And can others, non-trained, access to products? Do the reg installers offer system warranties?
Sure. Okay. So the registered installer scheme means that installers apply to us to then go on a training course, and then they do 2 to 3 jobs inspected by us, yeah, by Delta technical staff coming to site, etc., to make sure that the theory has been absorbed and it's being put into practice on real jobs, okay? So we can certify them from that point of view, and then we confer this kind of registered installer status on them, and then we can pass leads, if you like, jobs to them, still working with them hand in glove, to make sure that the standards are being maintained. Okay, so that's 99%, 99.5% probably of the way that we do things, because we sell to registered installers. Do we sell to builders? No, not generally. But there are circumstances when a main contractor or a builder will want to install the system, or the client will want them to install the system for various reasons. So what we would do then is we would say to the main contractor or the builder, we will work with you on this, and we will come to site with you, and we will help you with installation of our products in terms of the system, you know, that we've designed. But we will encourage you to come on a registered installer course to make sure that that you're installing the products correctly. So it can work in a kind of way where it's a little bit topsy-turvy, yeah? So instead of coming on the course and then doing the job, they can start the job under our supervision and then come on the course and then become registered that way. So 99.99%, it's a case of registered installers come to us and get qualified and then do jobs. Sometimes with the on the basis that it would be better to supervise them and then have them come on the course for everybody, then we sometimes do it like that as well, yeah. But in either case, we're heavily involved. We don't just sell the stuff like we're selling socks out of the box to all and sundry and not know where it goes or how it's installed or who's installing it. We think that would be an irresponsible approach. So we do everything humanly possible to maintain control of where our products go, who they go to, and we supervise and inspect and encourage people to come on the course, and that's been a successful way of doing it as we get further registered installers, you know, coming into the fold by doing it like that, but still in a safe and managed way. So yeah, we're very anal, Rosemary, about what we do, you know, who we sell it to. We're not in it to make loads of money. We're in it to, as I've said at the very start of this presentation, we're technical led. Yeah, we're led by standards and you know, best practice. So that translates into who we sell to as well.
That's brilliant. Thank you very much. I think we've covered most things on there, I think. So it just leaves me really to say thank you very much indeed, Michael. And also thanks to everyone who's joined us. I've had a lot of comments in the chat saying it's a really good presentation and thank you very much. Just a reminder, it will be uploaded onto our YouTube channel, and the link we sent out to all participants in the next couple of days. So if anyone has viewed today's session, think it would benefit a colleague, you can share that link with them. They can catch up at their leisure. And if you get any feedback on our webinars, please do email us on webinars@cbuilde.com. And if any of you actually would like to present one of our webinars or have an idea of someone who would like to do that, please do get in touch with us. We're always on the lookout for willing participants. So thank you very much again, Michael. I'll wrap that up. Thank you for your time, and hope we'll see everybody next month online.
Right. Thank you, everybody. Much appreciated.